Okay, right here, guys, in Desmos, let me show you what I did. I went in and put y equals, and it doesn't really matter what it is, but I put in a decimal so that this would be a wider picture so you guys can see it. Guys, this is what you're going to be doing, number 5 and 6 for your test, okay? I'm going to give you a function, okay? Now, you agree if y is equal to 0.6 x third. This is my red function. Then I did by hand, I did the first derivative of that. So 0.6 times 3 is 1.8 x squared. So this right here, this green function is y prime. This red function is y. And then what I did was I took the derivative again. So then I did a blue function, okay? So this is a blue function, and that was 3.6x right there. And it's not really so important what these functions look like. I mean, what these functions are. But what's important is this is your y. This is the derivative of y, and this is the derivative of y. Okay? And what we're going to do is this. I'm going to give you one of these pictures. Like, you don't know which one I'm going to give you. Okay? But if I give you y, so like if I gave you this red function right here, you're going to have to be able to kind of figure out what y prime might look like, okay? And if I give you y prime, you're going to have to try to tell me what y looks like or what y double prime looks like, okay? And there's a trick to it. And the trick is the first derivatives test and the concavity test. So let me show you what I mean. Okay, so first of all, I'm just going to trace this function right here. Maybe I'll trace, I'll trace this. This is y. Okay, so this is y right here. I'm going to take y, and I'm going to make everything else disappear. Okay, the reason is because I'm going to, on your test, I'm only going to give you one thing. I'm just going to give you y or y prime or y double prime. Okay, not everything. Hey, how come that didn't really trace? Sorry, I only got part of it. Okay, let me get this whole thing. Okay, so this is y, okay? Now remember, we don't know what y prime or y double prime looks like. So on your test, I'll give you y, and I'll say, hey, can you tell me which one of these choices would be y prime, okay? Well, if you know this is y, okay, you're going to have to be like, oh, okay, well, what would y prime possibly look like if this were y? Well, then you have to be like, okay, well, the slope, well, how about this? When y prime is positive, y is increasing, right? When y prime is negative, y is decreasing, right? So what I know from the first derivatives test, okay, is if I look at this y, I can be like, oh, look, y right here is increasing or decreasing. Let me go start from the left side, and I can see, oh, look, y is increasing, y is increasing, y never decreases. Does that make sense? Y never decreases, which means that tells me that if I go find y prime, it's got to be a picture where the y's are always positive. Does that make sense? So if I had a multiple choice, okay, if I had a multiple choice, and let's go back to this picture, if I had a multiple choice of which one y prime was, okay, and they gave me a choice between this green picture and this blue picture, I would say it has to be the one where y prime was always positive. And do you see y prime is positive here and positive here? Do you see that? It's always positive, whereas y double prime is positive here, but y double prime is actually negative right here. Do you guys see that? So you wouldn't pick that, all right? So it's not super easy to do, but what is easier to do is when they give you y prime. Okay, and that's what you guys see in your number 5 here. Y prime, because it's in the middle of y and y double prime, it's kind of like a middle child. Like, the middle child, you can see what the older child is getting in trouble for, right? And then you can also see how silly the younger child is acting. So the middle child can actually have a good feel for what the older child and the younger child does. So right here, if I take this and I trace y double prime, okay, and I go put y double prime I'm sorry, this is not y double prime, y prime. If I go trace y prime and I put it into a picture by itself, okay, and I tell you that this is y prime, okay? Actually, y prime tells me a lot about y, okay? And I can predict y double prime with it too, because when y prime is positive, y is increasing. When y prime is negative, y is decreasing. So the thing about y prime, because it's the first derivatives test, I can do a first derivatives test on it. So call this y prime, okay? Go get my critical point. Where is my critical point? It's wherever y prime is equal to 0, okay? Where is y prime equal to 0? Look, y prime is positive, it's positive, it's positive, it's positive. Where is it equal to 0? Right there, right? So that's called my critical point. This x number, oops, this x number here is my critical point. So this would be my critical point, x equals 0. And then I go plus, 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 minus, minus, minus. Well, where is y prime positive? Y prime is positive here, right? Where is y prime negative? It's never negative, right? So if I went into my y prime number line, I would be like plus, plus, plus on this side, plus, plus, plus on this side. So if I wanted to draw y, I would say, okay, if this is y prime, y would always be increasing. And then after 0, it would still be increasing. Does that make sense? So I kind of have a picture of what y looks like. This is your y, this is your y. And so if I went back, or if I had some multiple choice, I would pick some picture where y was doing, you know, something like this. I may not know the concavity, but I definitely know that y goes up and then it goes up again. Does that make sense? And so there are lots of things that you could figure out based on the first and second derivatives that will help you kind of predict what's going on with y, okay? All right, so that's what we're going to do here. Now, I'm only going to give you one of these graphs, not all three. And so you have to figure out with just one graph, how can we figure out things like where's the relative max, where's the relative min, where are we decreasing, where are we increasing? Okay, so let's look at number 6, and let's see if we can answer some of these questions. Okay, so I'm going to pull up number 6 here, if I can find it. Okay, right here. All right. Oh, no, number 5. Sorry, not number 6. Okay, number 5 says they gave you f prime. Okay, so make sure you understand they did not give you f. You guys good with that? So if I said, where is the relative max on f? Okay, you can't tell me it's here and here because those are the relative maxes on f prime. Okay, f is another picture. Okay, so be careful about that. So the first thing says, find the critical numbers of f. Okay, so this is an f prime picture. Now let's think about this. What's the definition for a critical number? The critical points happen when f prime is equal to what? How did you ever find your critical points? When f prime is equal to 0 or d and e, right? Okay, well, here is my f prime picture. Here's my f prime picture. So anytime that f prime is equal to 0, okay, this is my f prime picture. Anytime it's equal to 0, or d and e, which means it doesn't have a dot or it's undefined. Okay, let me put some arrows here. This is for all reals. Then I'm going to have a critical point on f. That's a critical point on f. Okay, so where, guys, is f prime equal to 0? Do you see f prime is negative here? And it's positive here, right? These are positive symbols. So do you see f prime is equal to 0 right there? Anywhere else where f prime is equal to 0? Right there, right? Anywhere else where f prime is equal to 0? Right there. So when they ask me for my critical points on f, okay, when I look at f prime, I know that that answer is x is equal to -3, x is equal to 1, and x is equal to 5. Do you see how to pull the critical points? The critical points are when f prime is equal to 0 or d and e, and so those were the places where my f prime had the 0 value. All right, next question. Where does f have a relative max? Okay, so remember, the picture of f is not on this graph, okay? I cannot pull f by just pulling these relative maxes. These are the relative maxes of the picture f prime, okay? Now, these boys all have different names, right? So this is my boy f prime. I can't get him confused with my boy f, who's in another room. You can't even see him in here, okay? Or he's on another slide, okay? So if I know f prime, How do I know where f has a relative maximum? That's where the first derivatives test comes into play. The first derivatives test helps you know when things are increasing, decreasing, or where you have a relative max or where you have a relative min. So remember, f prime is positive when f is increasing, and f prime is negative when f is decreasing. If you ever move from the top row to the bottom row, what you have is a relative max. If you ever move from the bottom row to the top row, what you have is a relative min. This is a relative max on f, and this is a relative min on f. Okay? So let's look at what I have. Remember what I said? If it's in the same row, they're synonyms. They're like exactly the same. So if f prime is positive, it's exactly the same as f is increasing. Okay? Well, my picture here tells me nothing about f, but I actually know a lot about f prime. Here's f prime. And what does f prime have to do right here? What does f prime have to do for me to have a relative max? What does f prime have to do? Has to change from what? Positive to negative, right? Anywhere where f prime changes from positive to negative. And guys, I can't stress enough. This part right here, if you've memorized this, plus the second one that we learned yesterday, you can pretty much answer 80 to 90% of things on the test, okay? So this right here, where does f prime change from positive to negative? Okay, well, here's f prime. Okay, now you got to move left to right because I'm still building my time machine and it's not done yet. So you can't go backwards. Okay, you got to go forwards. Okay, and you're going to go left to right. You're going to follow this curve. And when do you change from positive to negative? You agree f prime's negative here, right? And then it's positive here. Did I change from positive to negative here? No, I changed from negative to positive. Okay, so keep on going. This is positive. This is positive. Still positive. Still positive. Still positive. Might be a change here. Whoops. Still positive. Do you guys see I never changed to negative? Still positive. Guys, so where am I going to change to negative? Right there. What is that x value right there? Is it a 5? So f has a relative max when x is equal to 5. Okay? What's the justification? Because f prime changes from positive to negative. Okay, your justifications will show up on your quiz today. It'll also show up on your test next Thursday. Okay, is it next Thursday or maybe it's the next November 11th, whenever that is. Okay, all right. So then let's talk about relative mins. Relative mins happen. Okay, when you do what? When f prime does what? Here's relative min. What is f? Changes from negative to positive. So guys, look here. Where is my relative min going to happen at? Right there. And what is that x value? So you'll say x equals negative 3. What's the justification? Because f prime changes from negative to positive. Okay? Next, letter C. Okay? Tell me, what are the intervals when I'm concave up and concave down? Okay, relative max, relative min, increasing, decreasing, those are all first derivative things. Concave up, concave down, POIs, those are all second derivative keywords, okay? So let me go to my second derivative keywords, okay? This is really called the concavity test, but it should be called the second derivative test, but it goes like this. When f double prime is positive, f prime is increasing and f is concave up. When f double prime is negative, f prime is decreasing and f is concave down. If it's in the same row, they are synonyms. They're synonymous with each other, okay? If it ever changes rows, it's a point of inflection, all right? So here's the question. Where, okay, so this is f prime. I'm going to erase all of this, okay? How do I know when something is concave up? Okay, what is synonymous with concave up? This is concave up. How do I get a concave up? What does f prime have to be doing? Increasing. Okay, so knowing that, come over here and tell me, when is f prime increasing? Now don't get increasing confused with positive. They're not the same thing. Okay, when is f prime increasing? Start here, always on the left. I'm going to move to the right. Am I increasing here? Am I increasing? Yes, I'm increasing. Keep going. Am I increasing? Increasing. Okay. After this, am I increasing down here? No, so this is not increasing. Okay, this is decreasing, 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 oops, making a turn, going back up, increasing, right guys? Increasing, increasing, and then not increasing. Everybody good? So everywhere in red is where F prime is increasing. And F prime increasing, okay, is synonymous with F concave up. So the answer is, and see if this makes sense to you, all the intervals where I've highlighted in red. So F is concave up, so I'll say F is concave up on this interval. Negative infinity, I'm going to assume these go to infinity. So negative infinity to negative 2, okay, comma. That's how you'll do it on my math lab, comma. You can also do a union if you want, but that's a lot harder to do. So comma, and then go from, I think that's a 1. That's a 1, and then go all the way to, I think that's a 4. Okay, and that's where I'm concave up. Does that make sense? I'm looking at all the intervals where F prime is increasing. All right, what is the justification for this? The justification is F prime is increasing. You guys good with that? Guys, make sure you understand though, because on your quiz and on your test, it'll be a multiple choice. So it's not just F prime is increasing. What else could I have put if I wanted to? What's synonymous with F prime increasing? F double prime is positive. Okay, so either or, this is a happy face, this is a happy face, but you don't need to do both, okay? But I want to make sure you guys understand they're both the same thing, so if you had to choose from a multiple choice, you can look for both of those. All right, now you guys tell me. The next question is, where is F concave down? Remember, F is in another room, I can't see it, okay? But I only see F prime. So how do I know where F is concave down? Go ahead, write your intervals. Where is F concave down? Well, if I look at my concavity test right here, F is concave down is synonymous with what? F prime decreasing. So come up here and look to see where F prime, this is my F prime graph, where is it decreasing? F prime is decreasing here. It's all going down. And then, just follow it with your finger. And right here, F prime is decreasing. Okay? So F is concave down at, and I would say from, I'm kind of looking at it at an angle. So I'm seeing negative 2 to 1, comma. And then also, I think that is 4 to infinity. Okay? And what's the justification for concave down? Because. And then just go down and look at this shorthand that you guys write. You're going to write it right when you get the test. Okay? F is concave down when, Sydney, you're with us? F is concave down when, what's the justification for concave down? F prime is decreasing. Does that make sense? This is a great answer, but there's actually another answer that you could have if it were multiple choice. What's another possible answer? F double prime is negative. Do you guys see that? If it's in the same row, they're all synonyms. They're all justifications for each other. Okay? The one thing I want to tell you is this is never a justification. You can't ever use this last column for a justification. This is a definition. So let's go to the next question, and it'll make more sense. Number 6, okay, the question is, where do you have a POI? Okay, so remember, first derivatives is really good for increasing, decreasing, relative max, relative min. But when you talk about concave up, concave down, POI, you need to look at the second derivative, or sorry, the concavity test. So when F double prime is positive, F prime is increasing, F is concave up. You need to memorize this. F double prime is negative, F prime is decreasing, F is concave down. So when you rotate between the two rows, you have what's called a POI, okay? And what is a POI? Well, I'm given F double prime here. So this picture, guys, is F double prime. It is not F, and it's not F prime. And I want a POI on F, meaning if I could see my boy F, I wonder where his POI would be, okay? So what I have to do is, I don't know F prime, I don't know F, but guys, do I know F double prime? So what does F double prime have to be doing for me to have a POI? Changing from what? Positive to negative, or from negative to positive. Okay, so let's look at F double prime. Now don't get increasing confused with positive. Everybody's good with that? Where is F double prime positive? Positive means above the x-axis, right? So positive, positive, positive. This is negative, negative. These are all negative. Positive, 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 positive. Everybody good so far? Okay. Where does F double prime change from positive to negative? Tell me all the points. Here. Where else? Okay. Yeah, right here it changes from what? Negative, positive. So is that a POI if F double prime changes from negative to positive? Yes. Okay. Right here it changes from positive to positive. Is it a POI if you change from positive to positive? No. Okay. So the answers will be POI at x equals, and let me see what those numbers are, -4 and -1. Okay. Your justification will be, and this is the tough one. First of all, the easiest one is to say F double prime changes signs. You guys good with that? Because that's true, right? F double prime changes signs, okay? With the relative max and a relative min, you actually need to say from positive to negative or negative to positive. The POI, because you can go both ways, you just have to say changes signs. Okay, what's another justification? Let's say you can't find this one on your multiple choice. What's another justification? What does F prime have to be doing? Changes from increasing to decreasing or vice versa. Do you see how long that is? Okay, but it really is what this is right here. This is a POI if these things change, okay? Now, if you write this last one, it'll be counted wrong, even though it's not wrong. So if you write because F changes from concave up to concave down, or vice versa, okay? On your quiz and on your test, it'll be counted wrong. Even though it's true, that is what's happening at a POI, you cannot justify with F's. You have to justify with derivatives, okay? And the reason is because this is considered the definition of a POI, not a justification for a POI, okay? So make sure you're careful about that. Even though it's correct, it won't be counted right as a justification, okay? All right, so that's what I wanted to cover with you guys today. At this point, I want to answer homework questions and then also allow you guys to work on the quiz if you'd like to, okay? So what homework questions do you guys have? Do you want me to do any with you guys? You guys are totally good on homework? Okay, why don't you guys pull out your homework and I'll check your homework from, I don't know if we had time yesterday to check the first derivatives homework. And then last night you guys had the concavity homework. Yeah, so I need to check two homeworks. You have the first derivatives homework and the concavity homework. And the concavity homework was the one that said first and second derivatives. And then you guys just get started on your quiz. And once again, you can change your answer as long as you're still in that session. Does that make sense? But once you exit out of the session, it's going to lock your answers. So if you're not sure of an answer, does that make sense? Delete your answers. Does that make sense? Okay. But it'll lock your answers every time you exit the session. Okay. Yeah, yeah. Okay, so your quiz, guys, you got to hit test and quizzes to get in there, get into there. Yeah, yeah.
Can you do the quizzes during a weekend? Like you have a whole weekend to work on it?
Yeah, yeah, you can do that too. That's fine if you want to do that. On Monday, guys, we're going to start something new. We're going to do the second derivatives test, which you thought you did it, but actually it's a whole different test. And then on Tuesday, that'll be your off day. So your Monday night, your quiz will be due. You can ask me questions on Monday if you still have questions on your quiz. Tuesday, you're going to need to finish up your second derivatives homework. And when you turn that into Schoology, then I would check it off for you to be present on Tuesday. Does that make sense? That counts as your presence. And then on Wednesday, we will start doing a lot of these number 5 and number 6. Like it'll just be ton. All we'll be doing is like trying to guess what F looks like, not knowing anything about F, only knowing F prime and F double prime.